negative 3 sine t. Write the problem down. Oh, by the way, it goes without saying, whenever we're graphing in this class, your graphs had better be on graph paper. I won't accept this little sketch. No matter even if you draw the lines on your paper, people do that. No. Take a piece before you go so you're not out, find yourself at home without graph paper. You can always print some off if you have a printer. You can Google graph paper, print it, whatever, but it has to be on graph paper. First thing I need to do is I need to graph sine. But to do that, I need to think of an appropriate scale. And you are graded on not just can you graph this function, can you pick an appropriate scale so that the graph looks nice. I don't want these itty bitty graphs, nor do I want ones that go outside your graph paper or get cut off. So you're also graded on not only can you graph the function, can you pick an appropriate scale. Now, we want to see at least one cycle. So how far do I need to go? 2 pi at the very least. And what I tend to do for this section is I would stick with 8 squares. This is nice and neat. I don't have to worry about middle. So I'll make 2 pi be 8 squares, which of course makes that be pi. Now we all see a nice cycle in each direction. That's what I tend to stick with until next week, until we change the period. But since the period is 2 pi, I'm going to stick it at 8 squares. Now I need to think on my y. That's the hardest part for some people. I don't want an itty-bitty graph, but I don't want one that goes off the graph paper. Now, the negative, what is the negative going to do to my graph? It's going to reflect it about the x-axis. Big kids, right? Bless you. The 3 is going to stretch it. How high do I need to go on my y? How high if I'm going to stretch it? My scale. How high do I have to go? How high is sine right now? 3. Thank you. If it's 1 right now and I stretch it by 3, isn't that still going to be 3? Yeah? You with me? Common misconception is people think if it's 1 and you stretch by 3, it has to go to 4. No, 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 no. Saying stretch to 3. Okay? Do not go up to 4. Okay? So I have to go to 3 at the highest, correct? So am I going to make this 1, 2, 3? No. A little bitty graph, right? So I'm going to make it every 2 squares. 1, 2. And we have a nice good sized graph that I can see what's going on. I don't want these little dinky tiny graphs. Okay, now I need to graph sine. Now here's where I said if you didn't study last night, you're going to have a rough time. So I'm going to tell you right now on a quiz, if I ask you to graph sine and you graphed cosine or graph sine incorrectly, you get 0 points. None whatsoever. I don't care what you do afterwards. If you can't graph sine, you're in a heap of trouble. Okay? Sine starts at 0. And it also ends at 0, correct? Halfway between, where is it? Well, yes, it's at pi. Where on the y? Really? I think sine's still 0. Yeah. I think it has a max in between there and a min in between there. Remember I said you need to know start and stop? In between it's still 0. In between that it's a max. In between there it's a min. So graph your max and min. You need to be on the squares perfectly. Same over here. I know it's a 0. Min. Max. 0. Have to know what a sine wave looks like, and it has to be accurate. So I'm kind of like, the max is probably here. You need to have the max on a line, an intersection there. So I would consider this easy. Cake, bonus points. You need to know what sine and cosine look like. If you don't know that, you really need to study tonight like you should have last night. Okay. Now, question is, I have to stretch and reflect. Which one do I do first? I'm going to reflect first. If I reflect, it's still going to be tiny. Then I'm going to stretch. Because much yet, but. So what we're going to do is we're going to reflect. Now when I reflect, is that going to change my zeros? No. So the zeros are going to stay the same. Oh, this is a colored pencil. Notice I changed color. New step, new color. First one was in pencil, your original graph is in pencil, but now we have a step. Colored pencil. Now, this max is now going to be min. This min is now going to be a max. Max to min, min to max. And beautiful. Oh, Carol, what happened to the rest of your sign graph? They're not perfect, but they have a lot of trouble using negative effective, and that's up to start to pull graph. And try your best. These are curves. They should not have any points.
They're slightly curved. Hard.
Some of these are looking pretty.
Mine's
We
more-
need some practice. Because I'm seeing some
I got some diamonds.
curves.
That looks like a mountain range.
Okay, nice, neat curves. Okay, new color. Let's stretch. Now, when you stretch, it's like I'm taking the bottom, taking the top, and literally stretching it 2, 3. So I'm stretching 3. Yeah? So will that change my zeros?
No.
Not at all. Those zeros are still going to stay put. I'm going to take the one, don't take your original, take the one before it. It's going to go down to -3. This max is going to go up to 3, then down to -3, up to 3.
Wait, are we stretching your
The one we
original
just did. Nope, you're always building
Oh.
one step further.
No.
Try to make them curvy, not pointy. And last thing you do is you put arrows on your graph because it goes on forever and ever, correct? And you're going to write the word final in your final color. So I know which one is your answer. So draw arrow and write the word final in your final color. Okay, questions? Of course you have to know what sine and cosine look like. This is really hard. Let's try another.